Επόμενος ομιλητής μας, λοιπόν, ο κύριος Κώστας Μπαλαράς. Είναι διδάκτορ μηχανολόγος μηχανικός, διευθυντής ερευνών του Ινστιτούτου Ερευνών Περιβάλλοντος και Βιώσιμης Ανάπτυξης του Εθνικού Αστεροσκοπείου Αθηνών. Δραστηριοποιείται στους τομείς εξοικονόμησης ενέργειας και στα κτίρια. Έχει συμμετάσχει σε 38 έργα που χρηματοδοτούνται από την Ευρωπαϊκή Ένωση, από διάφορα υπουργεία και οργανισμούς και από τον ιδιωτικό τομέα. Ο κύριος Μπαλαράς έχει πλούσια συγγραφική δράση και είναι πυρογνώμονα σε θέματα ενεργειακών ελέγχων. Είναι fellow της ΆΣΡΕ και έχει περιττήσει σε πάρα πολλές θέσεις ως ενεργό μέλος, κατακτώντας και το αξίωμα του Αντιπροέδρου. Κύριε Μπαλαρά.
Thank you very much. So I'm going to make it official now. Thank you for participating here. It's a pleasure to see all these friends, colleagues, and distinguished guests. And I guess out of all this that we've been hearing and the previous presentations and the ones to follow, mine is kind of like fits in between. And this is really very well planned on behalf of our chair, Dimitri Atsidaftis, and our program manager who handle all this exceptionally, Dimitris Haralabopoulos, in terms of really now that we've heard the issues, the challenges, and from what Mr. Madas said about what we need, and from what you know from your own experience, the issues that you face at work, back at your design table, in front of your computer, when you're handling a new building or a renovation of a building, and the issues and the challenges that we have. And we're going to just try to touch on what are we going to do about it, how we're going to resolve and overcome these issues. Now, one of the most common buzzwords, in addition to energy conservation and so forth, is BEAM. Everybody's BEAM this, BEAM that, especially very popular with the architects, and the brilliance and the beauty of all this new features that we can add to our blue drawings, the blueprints, and the black and white, and the pen and pencil, and of course now, with all the capabilities that we have with computers, that we start saying, I can even show you today what you're going to be walking in tomorrow in your building, in your office, in your hotel, whatever. So with all this new features that we have with the physical and the functional characteristics of the building that we can describe and so forth. One of the key things, though, that we have to recognize in this early kind of like definition kind of a style is that we're sharing knowledge. We're sharing information. And of course, in terms of what we have seen with commercial available software and so forth, is one of the key features is that we're talking for a lot of data, for a lot of files, for a lot of database information that we have to manipulate. And of course, one of the other key characteristics of what BEAM is that an object-oriented building model. So it is as close as, especially, I always envy architects that could prepare these models and they could set in their offices and people could look. We now do the same thing in drawings, in CAD environments and so forth. But now we are also talking that we can link this data model to the analysis tools. And there comes the previous presentation from Mr. Madas when he said, well, now we want to simulate, we want to calculate, and we want to be able, and that's the big picture, we want to be able to follow the entire chain process, the different links, that the same building from day one when you met with a client and said, well, that's what I want to have, I want you to design, build, the first concept, all the way down to when we end up really demolishing the building. Could that be 40, 50, 100 years? We have examples of that. I used to work in a building over 100 years old, still operational, functional, everything well. So that is really what we would like now to fit in under the big buzzword of what we say BIM. Is this possible? Are there challenges? Are there issues? Of course there are. And with this work that it is currently underway, we're trying to address especially these primary stages: conceptual, design, and of course, when you move in the following to the construction. Because in the conceptual design is where the strategic decisions are being made, which are going to impact what is going to follow. Of course, there's always time to change things, but it's going to be costly. So in this decision-making process, the earlier you make the right decisions, the better off in terms of cost, in terms of success you be to make them at this stage. Now, out of all this, we can all gain, depending on where we are, because it addresses the needs of different stakeholders, of different professionals. Among you, there are various that pretty much fill out all these different activities. Of course, we have seen, and we're very comfortable with the 3D visualization of a building. What we're talking about now is being able to add to this a fourth dimension, like time, a fifth dimension where it involves also the quantities and the costs. And adding all these dimensions, you may say, now I'm losing it. What is he talking about? He's moving out of the 3D. I mean, phew, he's gone. No, taking into all this account, we should have all these features available to us under the same platform, right in front of everybody involved in the process, so that you can pretty much see what I mean. Other than the aesthetics, the 3D, the looks, the practical aspects, the operational aspects, be able to even, so that I can follow all the construction steps on time, predict when the new material will be needed, when this would be needed, and it is possible to put a duct after you have a ceiling to hang or to install it. And all these different materials you're going to be using and the cost and all these predictions. Now, adding this, of course, brings up complexity, but in terms of additional information from we're going to be collecting from commissioning, we have another excellent presentation coming up to figure out exactly what that means and the importance. In terms of operating the building, because right now in the hotel, there are the technical staff that operate and try to optimize the facility. And all this, now that's the key thing, in one model. Because all this is information available, scattered. What do I do? I have to do this. I take it from here. Now I need this. Oh, I have to redefine my problem and try to access this kind of a model of a method or whatever. If we can pull it all together into one beam model, then really the term, the concept, the idea becomes fully functional and operational for benefits. Mr. Madas presented this. That's where we stand. Kind of like big changes, especially for our visitors and guests over the past few years, that we have managed to go one step ahead. And definitely now we have, and we feel very comfortable, I said, that we are moving in the right direction. Of course, in terms now of the big picture that I mentioned before of where things are going, from the design down to the end of the life of the building, that's what the challenge for us is coming up by the end of the decade. In a few years, in 4 short years, that's what we're going to be called in to be able to design and construct and operate and look at all these different stages. We have tools. So I'm not going to be bringing you new ideas to say, I now developed this new tool, this new software, anything from performing thermal simulations to CFD analysis down to the very nitty-gritty details. I can see the air moving in here years before we occupy the building, because we can do that with CFD, all the way down to monitoring and having precise information of all the temperatures, of all the air flows, of all the air conditions, of everything. And of course, data and information are being added in all these stages. Now, Where we want to challenge, or we want to really try answering some of these challenges, is that definitely there has been a response. With all the different issues that we face with simulation, with building simulation and so forth, yes, indeed, the vendors, the commercial software, your very own favorite popular software that you use at your office, has all the features, all the bells, all the fireworks, and you're very comfortable working with. Unless, of course, you want to get information and access data from somebody else. Ooh, now I have to move to a different environment. I have to redefine my building. I have to do all these things. Issues, problems that you probably face on a daily basis at work. But definitely, we have made progress. And I'm not going to say that we do not have already available some of these features in some environments. But what we need and what we're trying to address here is to be able to actually perform and have access to various amount of data covering all the different priorities that I mentioned before that can be fed in during the design, so I make better designs, find better solutions, and try as many different scenarios as possible. Sky's the limit. Kind of introduced, Dimitris Madas introduced this concept of how much we need to do. But imagine this is going to mandate time, and this is going to mandate computational power, features that we're trying to resolve in this effort. All this information, the same information with the same BIM model should be available when we are also evaluating the needs, because the lifetime of building materials, equipment, and so forth, we know and we can estimate pretty much when it's going to end. And possibly, when I'm still in the design phase, I can make a better selection depending on the evaluation of the results, looking at what's going to happen to the building 20, 30 years. And of course, when you are already here, you can evaluate means and options that you can improve the performance. Now, with what we're going to be working with already in this effort, with having available various tools, specific ones, you don't care, the big concept we're trying to elaborate here, different CFD analysis tools, and data that are stochastic in nature. And again, Mr. Madas mentioned this. There's no definite thermal conductivity property for a building material after 20, 30 years, depending on how much exposure it had at the different weather conditions and so forth. We always start with what the books, the standards give us, because, or the certificate of the material give us to start with. What's going to happen after that? Nobody's really know, again, he touched and underlined this with occupancy. What's going to happen? Someone, the owner, said, there are going to be 150 people in here. What if we had a big success, a big event, and we crammed 200 people in here? So there may be some uncertainty, and all this, of course, is much better understand when we're talking about weather and climate. What's going to happen to my building that is located in the north, the suburbs of Athens after 20, 30 years? How would the climate react, change, even the microclimate, and how would the building react to this? So all these different needs, all this different data would be stochastic in nature. And that's where we start making a big contribution, and we're moving in the right direction. We have actually tried to be able to communicate this information on the general level, not for a specific software. Knowing the input, knowing the software, you can make the link. They already, everything that you use at your office actually has established this. It's pretty simple. You know what your available information would be, thermal properties, optical properties, efficiency, COPs, blah, 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 for your specific software. So one-to-one, no issue, no problem, move on. Well, I have different libraries because I have thermal properties from one source, optical properties from another source, and again, the commercial software, the vendors, pull them together, And as I said before, they give you all the fireworks, everything, make it easy for you to use. And again, no issue, no problem. But now that's started becoming complex. To be able now to share the same information without going again and redefining the problem of the building, of the properties of the materials, just because I went from my thermal simulations to my CFD. It's the same building, it's the same problem. I just want to look thermal energy consumption, and I want to look thermal comfort as a result of the air motion, indoor lighting levels. Don't get me again to say that I have to define the problem over and over again. Don't tell me that I have this data, but no, you cannot use it here. But I know it. No, you cannot use it because the software cannot understand it's not the right format and so forth. So these are the issues. They're missing pieces and parts, and that's the solution we're working with in order to develop a common language. A common language means you have to collect all the available data in a format that it's easy to communicate regardless of what the end user, the software, the tool would be, so that they can all, we define open and clear language of communication in a way that now we pretty much all can understand what I'm saying because I'm speaking in English. So before we had a presentation in Greek, so some of our guests couldn't follow. So now we can all participate. We found a way to communicate. In a similar fashion, with all the different resource available information, as I said before, we're looking at the different weather data, of course, materials, of course, because you can all understand what that difference makes, the building elements, and the occupancy, the different schedules you may have in the building. They all being processed so that we have a template where all the information is collected, clearly defined by industry standard in terms of ICT technology, so we all know what it is, documented, and then you pass that information to different tools. Already in this effort, we had a list of different tools, as you see here, for thermal simulations and for CFD analysis. This is for test driving the concept. We don't care. You may have seen your favorite software on the right-hand side. You don't see it there, but there are tools already existing. We want to develop, and we have developed this big idea, big concept. There was a starting point, we have to admit. This is a European project, a European research project. A similar effort, and here's the website. It's nearing completion. So that kind of gave us the basic services framework that now, in this current effort, we were able to build on and develop, so that we can include in these templates, in this general language definitions, the different technical requirements, regulatory requirements you may have locally or nationally. And this pretty much shows the nitty-gritty details of how this information is going to be manipulated, processed, so that that's where it becomes practical for us right now, is so that I can finally, taking advantage of all the different data, information, and so forth, organizing, I can use the right simulation model. One definition carries all the information or refined information for the specific problem in order to be able to perform the different simulations for the different scenarios, for the different issues and problems. I throw that in there, little details. For some of you may be interested to know exactly what each step and what the flow diagram goes in there. I'm not going to spend too much time, but it will be there for your reading pleasure. But I'm going to spend time now going through the code that was prepared so that you fully understand word line by line and everything that goes in there. No, even from a distance, yeah, it looks scary. It means, though, it takes some expertise. And that's what the group provided. This expertise to define this language so that it creates some expert knowledge to create the templates, but then the dirty work is being handled underneath internally. And for those of you, I see some faces here, yeah, give me more. I want to know more about this. This is also already available so that if there is some interest to know how things like that can be handled, solved for your own benefit, already deliverable that addresses all these issues that you can access. And well, practically, what are we talking about? Finally, what we have achieved, and it's one step already, and I'm going to get up here, so I saw, well, I've managed to get up to a point. We're not done yet. Is that I can manage, I can access, I can retrieve data from different sources and include different and variable functionalities so that I can run, execute a different tool, which means a different code. And at the same time, take into account what so nicely and kind of like Mr. Madas introduced, that we really don't know. And you pretty much in your design work have realized this. You really don't know whether that was going to be the occupancy, whether that would be the outdoor conditions, whether that would be the thermal properties of the building materials. We go by code. We know what we're obliged by Knack to do our calculation simulations, but we all have a feeling this is not going to be true even day one, but after 1, 2, 3, 5, 10, 20 years down the road. So one example of how we are handling this stochastic nature of weather data we have been really handling with our group at NOA is to really follow this concept. We already had this weather data available that we can use, and how we went through this process so that at the end, once we're able to select the different weather parameters that we want to use, to provide an accessible this climatic data to the different tools to use, whether that would be a thermal simulation tool, whether that would be a CFD tool. They're all just tools looking for information, and now we have bridged this communication gap so that even as a user, you would be able to say, well, let me look at the test reference here, which is typical. Most of you, that's what you use. Let me look at specific extremes. Let me look at the frequency of the specific extremes, if, of course, weather data is available, and having, of course, the privilege of having this historic data, we are able to do so. But all this sounds pretty strange. That, again, by just saying, I want to perform thousands of simulations, thousands of different parameters to investigate, thousands of different scenarios. Thousand, it's going to just make it mission impossible to really do your work. And that's, you don't want as a designer, as a professional engineer, spend the rest of your life solving one problem. So you need muscle, you need computational power. And the solution, as we know, comes from this another practical technological achievement solution with a cloud computing. I don't want to buy all this computational power for my office, but it is available for you. I don't want to be able to access the data only from my office. I want my colleague on site. I want the architect, the engineer, to be able to share at the same time the information, the changes that I have made as a civil engineer. So all this sharing, common, accessibility and so forth, and computational, of course, power is provided by cloud computing. We have moved long ways, even from the great advantage of sitting at your office and having a really high-tech, powerful computer. Now, really, we have very big opportunities. But the other big challenge is, of course, what am I going to do with all the thousands of results you're going to provide? One of the challenges now, we are in this stage of looking, is how to manipulate, how to provide to the user, to you, all this information so that you can screen the different results, the thousands of results that you were able to generate, that you were able to compute, in order for you to make some good design decisions to really reach your objectives. And that kind of like shows the different ideas with the different criteria that you may be setting, whether it's energy per unit floor area, whether there are environmental emissions, or whatever criteria you may be using to see the combinations, the possible different scenarios that you can assess in a productive and meaningful way. That, of course, is underway. I get really into the nuts and bolts, into the details, someone would say, oh, God, I thought this would be interesting. So what's in it for me? Well, I mean, you're all here to kind of like, yeah, okay, so is that just like in your research office, another European research project? More interesting, but what am I going to use? Well, there's going to be really something very practical. Under or close to within the next year, we're going to finish this project. We're going to have a virtual laboratory available to you so that you will be able, and that's the big picture, have available data that you can enhance with your own. Have and address the different issues that, as I said, weather, the stochastic nature of the weather, of the building material properties, of the occupancy, and so forth. Generate one BIM model, one, that then would be communicated and the flow of information properly screened so that it will be fast, moving in and back and forth the information that you only need, in a way, though, that once it reaches the different configurator where you set up the scenarios, you can decide, I want to look at this parametric analysis. I want to look at all the different schedules, occupancies, the uncertainties that we were discussing before, or the issues you want to address. Get the computational power, because you're going to put it out in the cloud. Whew. And you say, well, now, they're going to do the dirty work. And the dirty work is going to return, really, a lot of information. You're going to be back in here. So now is what I said, the final stage, where you want to be able to massage this data, process this data, and be able to look at really a vast amount of information in a meaningful way, because we're still humans and we're trying to make reasoning out of all these results so that at the end you'll be able to reach the decision whether you have to go back to your original design or whether you like to solve or try a different scenario and so forth. So all this is a virtual laboratory. You will have the available tools. Eventually, there may be a possibility that in the commercial development, once we're done within this project, we're going to have a prototype to add specific tools, because you may feel more comfortable with the X and Y simulation software or CFD software or whatever, to be able to integrate it, because all the methodology, the principles, the cables, the networking is there for the information to start flowing. And hopefully, that's the intention, to make our lives easier in order to achieve a better indoor building environment. This is a joint effort. Have to give credit to the TU, Technical University Dresden, that really are the coordinators of this work, and the distinguished other partners, all within FP7 research project. And maybe, if all this kind of like, interesting, but I really didn't follow all the details, that's maybe one of the most practical information that you'd like to note. It's going to be available for you to access, and please do follow. And hopefully you will join the experience of the virtual laboratory once it's available and goes out public. Thank you very much.
Κώστα, είναι φοβερό ότι όλοι ξέρουμε ότι είσαι εξαιρετικός ομιλητής. Δεν ήξερα καν ότι μπορείς να χρονομετράσεις και τα 2 λεπτά που είχες πάρει τη εξαιρετική ικανότητα. Υπάρχουν ερωτήσεις? Ωραία.
Αυτό το οποίο παρουσιάσατε στηρίζεται στο cloud. Ο σχεδιασμός τον οποίο μας είπατε στηρίζεται στο cloud. Οι μεγάλοι ενεργειακοί καταναλωτές στην Ελλάδα είναι κυρίως ο χώρος των τραπεζών που έχουν και διαχειρίζονται πολλά κτίρια και βεβαίως μεγάλα συγκροτήματα. Μέχρι τώρα το κομμάτι του cloud στην Ελλάδα είναι πάρα πολύ πίσω. Η περίπτωση εφαρμογής στο μοντέλο το συγκεκριμένο το οποίο παρουσιάσετε, που στηρίζεται πάνω στο cloud και δεν είναι server-based εφαρμογή ή δεν είναι client-server μοντέλο, πόσο το βλέπετε ρεαλιστικό να εφαρμοστεί?
Εγώ προσωπικά δεν είμαι ειδικός, ένας μηχανολόγος μηχανικός είμαι. Για το cloud είναι συγκεκριμένα το Πανεπιστήμιο της Λιουμπλιάνα που προσφέρει τις υποδομές. Όσο γνωρίζω το cloud είναι ότι ουσιαστικά δεν ξέρω πού είναι και δεν με ενδιαφέρει πού είναι. Άρα το πού έχει καθίσει αυτό το νέφος, μπορεί μία μηχανή να είναι στη Νότια Αμερική, η άλλη στη Βόρεια Ευρώπη και η άλλη στην Αυστραλία. Δεν ενδιαφέρει κανέναν. Η συγκεκριμένη πάντως υποδομή, γιατί εμείς έπρεπε κάπου να στήσουμε το δικό μας νέφος, δεν χρησιμοποιήθηκε υπάρχον εξωτερικό, έχει και κάθεται και θα κάθεται. Αυτή είναι και η σύμβαση που θα υπάρχει με το καλό όταν ολοκληρωθεί το πρόγραμμα, θα κάθεται στο Πανεπιστήμιο της Λιουμπλιάνα.
Αναφέρομαι στο κομμάτι των data, γιατί η χρήση των data από πλευράς κτηρίων, το να μπορούν να αποθηκευτούν στο cloud, δεν έχει εφαρμοστεί και δύσκολα θα εφαρμοστεί στοιχεία από τους οργανισμούς να μπορούν να αποθηκεύονται εκτός του οργανισμού. Οπότε ωραία. Η έννοια του cloud δεν έχει να κάνει με το process power, το οποίο προφανώς. Αναφέρομαι στο δικτυακό κομμάτι, το οποίο έχει πάρα πολύ μεγάλη σημασία η ιδιωτικότητα των data.
Η απέτηση της πληροφορίας κλπ. Είναι ότι κάποια στιγμή θα πρέπει και θα έχετε στη μηχανή σας το αρχικό BIM σχέδιο, το οποίο θα αρχίσει να εμπλουτίζεται ή θα αρχίσει να παίρνει τα δεδομένα που είχα στην προηγούμενη διαφάνεια από αυτό εδώ το κομμάτι. Τώρα, η επικοινωνία και το τι τελικά θα πηγαίνει να κουμπάει, που πιθανότατα είναι θέματα ασφαλείας και πρακτικότητας, είναι σαφές ελεγχόμενο το τι θα πάει, τι θα κουμπίσει και τι θα γυρίσει. Αυτό που θέλουμε να εξασφαλίσουμε είναι ότι τα 5, και δεν ξέρω πόσα μηδενικά ακολουθούν, δεδομένα που θα χρειαστώ, μπορούν να οριστούν μία φορά, έτσι ώστε από εκεί και πέρα σε όποιο επίπεδο και για όποια άλλη προσομοίωση που θα προσπαθήσω ή ανάγκη θα έχω να κάνω, αυτός ο ένας αρχικός ορισμός έχει όλα τα δεδομένα από τη θερμική ιδιότητα μέχρι το κόστος ή μέχρι το πότε θα έρθει στο γιαπί και το περιμένω και έχει γίνει παραγγελία, άρα όλοι καταλαβαίνουν, το αναλαμβάνω, για να μπορεί να επικοινωνεί και να διαλέγω και να παίρνω έτσι ώστε να τροφοδοτήσω μετά είτε τα υπάρχοντα εργαλεία που υφίστανται και θα είναι διαθέσιμα στο χρήστη και είναι καλό ότι μπορείς να έχεις εκεί, αντί να κάνεις την μεγάλη επένδυση να προμηθευτείς ένα συγκεκριμένο λογισμικό, να έχεις πρόσβαση, να τοποθετήσεις και το δικό σου. Άρα, αυτού του είδους και αντιλαμβάνομαι της ασφάλειας δεν έχει εντοπιστεί ότι παραδίδω τα σχέδιά μου και τα τοποθετώ και οποιοδήποτε μετά έχει πρόσβαση και άξιση σε αυτό.
Υπάρχει κάποια άλλη ερώτηση? Μισό λεπτό να έρθει λίγο το μικρόφωνο για να ακούγεσαι.
Ήθελα απλώς να ρωτήσω στο Virtual Laboratory αυτό που λες, Κώστα, τι θα μπαίνει κάποιος, ας πούμε, να κάνει, να δει από τους εξωτερικούς, όχι από τους συμμετέχοντες στο πρόγραμμα.
Θα είναι ένα περιβάλλον.
Δηλαδή μπαίνω εγώ τώρα το βράδυ, πηγαίνω στο σπίτι, μπαίνω να δω τι ας πούμε εκεί.
Απόψε το βράδυ δυστυχώς.
Εντάξει, θέλω να πω.
Αλλά σε περίπου ένα χρόνο, αυτό που θα έχει τη δυνατότητα θα είναι εργαλεία τα οποία είναι διαθέσιμα, έτσι ώστε τροφοδοτώντας το με το δικό σου BIM κλασικό, να ενσωματώνονται και να μπορούν να μπουν οι πληροφορίες που μπορεί να έχεις και θα έχει από δομικά υλικά, από κλιματολογικά, από διαφορετικά schedules, αυτά τα βασικά που είπα, που θα χειριστούμε και τις ιδιότητες των θερμοφυσικές ιδιότητες των υλικών, έτσι ώστε μέσα σε ένα περιβάλλον που επίσης θα σου δώσει για να χειριστείς το τι θέλω να κάνω, τι θέλω να δω. Θέλω να δω τη μεταβολή της θερμοκρασίας από τόσο έως τόσο, επιλέγοντας συγκεκριμένα παρελθόντα έτη για μια τοποθεσία που υπάρχουν τα δεδομένα βεβαίως ή το τι προβλέπεται να γίνει στα επόμενα 50-100 χρόνια. Θα ήθελα να δω την στοχαστικότητα και τη διαφορετική ή τις αλλαγές στα occupancy schedules, στη χρήση των κτηρίων, από αυτού του είδους τις διαφορετικές, αν αλλάξουν τη χρήση ξαφνικά από αυτό το χώρο συνεδριάσεων, συναθρήσεων, το κάνουν γραφείο. Τι θα γίνει? Όλα αυτά λοιπόν θα τα ορίζεις μέσα σε το περιβάλλον που θα σου προσφέρεται, θα τρέχει, και μετά θα βγάζει και κάποια αποτελέσματα που πάλι στο περιβάλλον που θα σου προσφέρεται θα βάζεις τα κριτήρια στην επιλογή, στην ιεράρχηση, στο και να δω και αυτό και εκείνο και το άλλο, για να μπορέσεις να αποφασίσεις αν τελικά θα ξανεπιστρέψεις, να αλλάξεις κάτι και να το αφήσεις πάλι, να επαναλάβεις το τρέξιμο κλπ. Άρα λοιπόν θα είναι ότι όμως μπορεί να μην έχει το αγαπημένο σου λογισμικό. Μπορεί να μην έχει το εθνικό μας λογισμικό. Άρα όλα αυτά, από τη στιγμή που έχουν τεθεί οι όροι, το πώς θα επικοινωνούν και μπορείς να το εντάξεις μέσα, αυτό μάλλον είναι μια λεπτομέρεια που δεν μπορώ αυτή τη στιγμή να το απαντήσω. Όταν θα γίνει το συμφωνητικό, γιατί θα υπάρξει μετά υπεραιτέρω συνέχιση, κάποιες από τις εταιρείες που συμμετέχουν μέσα, εμείς είμαστε ένας δημόσιος φορέας, αλλά υπάρχουν κάποιες εταιρείες που έχουν συμμετάσχει σε αυτό το έργο, που θέλουν να το αναπτύξουν και εμπορικά να προσφέρουν λοιπόν αυτή τη δυνατότητα με τα δικά τους, αλλά και με πιθανά άλλα λογισμικά που θα μπορούσες να εντάξεις μέσα για να κάνεις πιο εύκολα τη δουλειά σου.
Ας μου επιτραπεί μια μικρή παρένθεση, χωρίς να κάνω κατάχρηση της θέσης του Προεδρείου. Ουσιαστικά το cloud θυμίζει το theory of everything στη φυσική. Ουσιαστικά έχουμε λοιπόν τα δεδομένα αυθύπαρκτα. Μιλάμε λοιπόν για entity relationships models, δηλαδή τα μοντέλα λογικής απεικόνησης των πληροφοριών, που είναι το ένα κομμάτι. Το δεύτερο κομμάτι είναι τα μοντέλα της φυσικής αποθήκευσης, το storing και οι αλγόριθμοι hashing και οτιδήποτε άλλο συμβαίνει για να έχουμε πρόσβαση. Όλα αυτά είναι το φυσικό επίπεδο της πληροφορίας και το λογικό βέβαια στο entity. Φτάνουμε μετά στο σημείο το κρίσιμο για το privacy, αλγόριθμοι κρυπτογράφησης, οι οποίοι δυστυχώς, για να μιλάμε και την αλήθεια της ζωής, η Adobe, παραδείγματος χάρη Adobe, είχε σοβαρό πρόβλημα όταν ανέβασε cloud τις εφαρμογές και είναι ένας από τους κορυφαίους provider λογισμικού στον κόσμο. Πέρα από όλα αυτά υπάρχει και ένα τρίτο layer, όλα εκείνα τα εργαλεία με τα οποία θα έχουμε πρόσβαση, accessibility πάνω στα δεδομένα και πόσα από αυτά θα είναι common share και πόσα θα έχουν access rights violations. Προφανώς το cloud είναι κάτι νέο. Απαντάω λοιπόν στο φίλο και σε πολλά σημεία συμπορεύαμε μαζί τον κύριο Παπαδόπουλο. Ναι, το cloud προφανώς είναι πρόκληση και αν μείνουμε static θα χαθούμε, οπότε ας πάμε στα βαθιά και ό,τι βγει.
Ευχαριστούμε πολύ, κύριε Μπαλαρά.